All right. So it seems like we're ready to go. Well, good morning, everyone. Thanks for coming. Yes. Actually is on, yes. I have to maybe speak up a little bit even more into the microphone. So welcome to our talk. Restricting the scripts, you're to blame, you give CSP a bad name. So if you like bad puns and you know Bon Jovi, then you know how this title got to be. This is work between myself and my student Sebastian, who's going to do most of the heavy lifting of this talk. But it's based on, since we're academics, joint work with a couple of other folks, namely Tim Barron, Nick Nikiforakis, and Stefano Casavaro. So who are we? So first off, this is Sebastian. Sebastian, as I said, is a PhD student in my group at CSP. So I'm a faculty there, so essentially somewhat of a professor, but not a professor. And so, as I said, we are academics, but I like to come here a lot. And it's very cold in this room. Otherwise, you would see that I'm wearing the 2013 OWASP AppSec Research Europe, I think it was called back then, T-shirt. So I've been doing this for a while, whereas for Sebastian, this is actually his first talk. So if you think the talk sucks, blame it on me and not on him. Okay? I just want this to be very clear. All right, so why are we here? Well, to be honest, we did a survey of CSP, and looked at the deployment of CSP over 10,000 sites between 2012 and 2018. And we found one thing that is not particularly surprising. Well, CSP is not particularly widely used. Okay, and this is nice in terms of research, and there's many more questions that we answer in the paper that will hopefully come up very soon. But this is not a scientific conference. This is more of a, well, developer and, well, practitioners conference. We wanted to go to Amsterdam. I think for you, it's the first time in Amsterdam. I've been here before. But importantly, also share some of our insights that we gained from this longitudinal analysis. And to be fair, we also want to learn new stuff from all of you, because again, I'm saying it moreover, we're academics. So we have this nice view on the world, saying, CSP is easy. Well, that's not everybody deploying CSP. We'll find some interesting things along these lines. But importantly, we would like to understand how can we make CSP better based on the needs of the people that use it, right? Rather than somebody in the ivory tower saying, hey, this should be easy to use. All right, so now that I've introduced ourselves, let's first have a look at who are actually the audience. Who is the audience here? So let me ask you a couple of brief questions. Who has heard of CSP before? All right, that was somewhat expected. Who has tried using CSP for their site? Who has run into some functionality issues when deploying CSP on their site? What a surprise. And who thinks they are running right now a CSP that is secure with respect to content restriction? I will not tell you what secure is, but okay, awesome. So let's discuss if that's actually true or not later on. But essentially now my job is done, right? So I've answered the question that we set out as the talk title, namely that securing content is virtually impossible to do securely with CSP. However, CSP actually has made a bit of development over the years to try and address exactly these problems. So let's have a look at when CSP was first deployed. So you have a small example script here where we have an HTML element or a script tag that is from ad.com. And as you know, ads like to add additional content to the document. So we also know that it adds stuff from from company.com. And then we also have a meaningful inline script which implements some functionality. And I think this is a standard use case that you might have on a lot of sites. So in level 1, this would be the policy that you would need to deploy, right? You have script source, ad.com, company.com. So explicitly whitelisting those two origins, and you have unsafe inline because you have an inline script. If you have unsafe inline, you're not secure by default because any attacker can just inject the script into your page and you're screwed. So then at level 2, we actually have an improvement here. So now from level 2 onwards, we can use nonces and hashes to explicitly say, this particular inline script is coming from my site. And now all of a sudden we have a policy that looks something more like this, right? So we still have script source company.com because, we can nonce the script from ad.com. We cannot do this for company.com because it's ad.com's, job to do that. So we also have to add company.com. And this is also where in many cases you run into functionality issues because what happens if ad.com now says, beforehand this was BMW that we showed you, now we show you Mercedes-Benz. Right? So all of a sudden they add a script from Mercedes-Benz, your CSP breaks, you don't get any money from the ad company. So that sucks as well. So then in level 3, there was another feature being added, which is called strict dynamic. And the idea behind strict dynamic is that if you have a script that is already nonced or explicitly trusted through a hash, that script can programmatically add additional scripts. And so this is essentially shown here. So we do document create element script, then set a script source and append the document, the script to the document. And so now this is the policy. We can have very long discussions whether strict dynamic should be called strict dynamic or not. Could also be called unsafe dynamic. But essentially we get rid of this problem of trying to maintain our whitelist. And that is assuming that the third parties that we include only add scripts programmatically. Okay, so they cannot use document write. So now that we have some idea about CSP and what it looks like, I told you in the beginning we did this analysis from 2012 to 2018. You might wonder, wait, so you said you were here for the first time in 2013. So how have you been collecting data for essentially 7 years? The answer is I have not. But there's a very nice service which is called the Internet Archive. And that has been archiving websites since, I guess, 96. And importantly, they also collect all HTTP headers that they encountered when crawling those sites. They don't deliver them as actual HTTP headers, but they prefix them with this xarchive oric. But this also means that we can easily go back in time, essentially, look at a fixed set of sites, get out the snapshots between, well, in this case, 2012 and 2018, and for each time just extract this xarchive oric content security policy and content security policy report only header. And so what we have seen, and this is where we get to the very academic part with graphs and so on, CSP level 1 was really sucky, right? And we can classify a policy as being CSP level 1 because it does not have nonsense, it doesn't have hashes, it doesn't have strict dynamic. And so if we look at this graph, we see that the adoption of CSP is growing over time. So this is like, yay, good trend. We would like to see this a lot. We can also see, clicker, that here at the end of our experiment, actually CSP level 3 is the most widely used level of CSP. And again, this is not because CSP has versioning information, but because, for example, there's a strict dynamic keyword in the policy, so we know it must be level 3. So this seems to be an actual good sign, right? So people thought about what is bad about CSP, how can we improve it? They came up with things like strict dynamic, and now there's a rise in the adoption of CSP. However, as you will learn now from Sebastian, this is not necessarily only due to the great ability for content restriction, but for many other reasons as well.
So, as Ben already mentioned, the overall adoption of CSP is increasing, which is great. But as you can also see on that dashed line, only a third of the policies are actually using CSP to restrict script content. And well, as Ben also mentioned, script content was the original use case of CSP. So naturally, this means that in the new versions of CSP, also other use cases of the security features were implemented into the policy. But let's first take a look into the script content restriction capabilities of CSP. Well, Ben already asked you about whether your policy is secure or not. And there are a few practices or source expressions that you can use in CSP, which basically makes the policy trivially bypassable. For example, unsafe inline, which allows the execution of inline scripts, or the whitelisting of complete schematas, such that, well, basically every HTTPS origin is a valid origin. And also data UIs, which are kind of similar to inline scripts because you can place your scripts in an URI. So no one should. Those source expressions make your policy trivially bypassable, and here we are not even talking about things like open redirects, JSONP, or script gadgets. So no one would, well, use those insecure values in their script source policy, right? Well, the real world shows a different picture, because the usage of those unsafe practices is dominating the script content controlling policies. Especially unsafe inline is used in, well, around 90% of all script content restricting policies. In our opinion, this is due to many web applications using inline event handlers, which is basically only possible if you use unsafe inline. And therefore, the usage of the unsafe inline keyword is still that high, although things like hashes and nonces and strict dynamic are implemented into CSP nowadays. So it's sorry. So deploying a CSP seems to be really hard because everyone is using those unsafe practices. But let's take a look into a few examples where people actually manage to deploy secure policies. For example, GitHub. Well, they initially started in November 2013 with an already secure policy in enforcement mode. And here their script source only contains 5 entries, which were basically GitHub itself and content delivery networks and some analytics. Then in May 2014, they actually combined all their script assets and scripts from their CDN and built their own CDN and moved all their assets there, and also reduced the number of analytics companies that they use. And then, they have only 2 entries left there, but they even further improved in October 2014 by completely removing the last analytics company that they trust, Google Analytics in this case. And now their script source directive only contains their own CDN and nothing else. So, which is, a secure policy. And throughout their whole journey of deploying CSP, they never ever used any of those insecure source expressions that we have seen before. So it seems to be easy, right? However, GitHub is not a small organization, and also don't really need third parties, like, for example, Maps integration and stuff. So let's take a look into another example. For example, Airbnb. Well, and as it is suggested for deploying a CSP, they started with a policy in the report-only mode, where the directives are not enforced, but in case of violations, a report is sent to a specified URI. And they started with a script source that, contains already 17 entries. Then later, in March 2015, they added the whole HTTPS schema to their website, probably due to the high number of violation reports. And then in May 2015, they actually switched their report-only policy to enforcement mode, but with a reduced number of entries in their script source policy. But one of those entries still being the whole HTTPS schemata, so it is still completely insecure. Then, 2 years and many changes later, where they keep on adding new domains to their script source policy, they actually started to again deploy in parallel a report-only policy, which was enabled for 1 day and then disabled, and new domains being added for the next, I think, 1 month. And then, in January 2018, they again try with that hardened report-only policy that did not contain HTTPS. And, they changed this secure policy in the enforcement mode. However, this seems to have not worked well, because a few hours later they changed it back and added HTTPS again, most probably due to fatal errors in their application, because some of their assets were not be able to load. And then, after adding some more entries in their script source policy, they finally arrived with a secure CSP containing 33 entries in the script source. Well, Airbnb's main business totally depends on their web presence. And, well, Airbnb is also a big company. But they still needed more than 3 years to actually deploy a secure policy that is enforced. So, what have we learned for the script content control capabilities of CSP? Well, most CSPs in the wild do not effectively protect against market injection, simply because insecure practices are used in nearly every policy in the wild. And that building a secure policy requires a massive amount of time and engineering effort, as we have seen in the Airbnb example. So, as already mentioned, there are also other use cases for CSP. And one of those use cases is to enforce secure network connections. Well, using HTTPS is important, and I think we all agree that everyone should use HTTPS in their web application. And CSP actually is capable of enforcing those secure connections. And as you can see here, the usage of CSP for enforcing TLS connections surpasses the usage of the script content controlling CSPs since August 2018. But how can you actually enforce secure network connections using the content security policy? Well, for CSP level 1 and 2, you have to basically whitelist only the whole HTTPS schemata, so every source that is not an HTTPS source will be blocked. But because that's, well, a kind of weird policy, they decided to add cool new features into the CSP level 3, namely 2 new directives for block all mixed content, which, as the name suggests, blocks all HTTP content if it is present on an HTTPS page. And upgrade insecure requests, which basically upgrades all HTTPS requests that are issued by the web application to an HTTPS connection, which is pretty cool, especially if you want to migrate a web application from HTTP to HTTPS, because you don't have to change all the links that are hard-coded in the web application. And because people obviously don't want their applications to break, the directive that is mostly used for TLS enforcement is the upgrade insecure requests directive. And, well, it maybe upgrade insecure requests is also one of the reasons why the HTTPS adoption in general is increasing in the last years. But what we can also see here is that the, well, rise of CSP level 3 that you have seen in, well, Ben's part of the talk is most probably not due heavy usage of strict dynamic, but because upgrade insecure requests is a, well, CSP level 3 directive, we can attribute the increased usage of CSP level 3 to upgrade insecure requests. So, to further investigate if people are actually using upgrade insecure requests in process of migrating their web application from HTTP to HTTPS, we take a look all main pages of those sites that use upgrade insecure requests according to our dataset. And we collected all external URLs that we found on their start page. And here we actually have seen nice examples of people actually using it for a transition to a secure network connection. For example, Riot.com. They started their deployment of HTTPS in June 2016, but they had HTTP links on their main page until September 2017. So to further investigate if this cool feature can be used on more web applications, we crawled the live version of the 10,000 websites that were in our set. And on nearly 4,800 of them, we found mixed content on their front pages. And, well, we also checked whether this HTTP content is also accessible via HTTPS. And here we see that nearly 90% of them were actually accessible via HTTPS. So they can actually use upgrade insecure requests to get rid of all mixed content problems, at least for their front pages. So, what have we seen for the TLS enforcement capabilities of CSP? It is awesome to use to secure connections because you have basically only to add one single directive to your policy, and it makes also the migration from HTTP to HTTPS much easier because you don't need to immediately change all links in your application because upgrade insecure requests does that on the fly. And what is also important here as a takeaway message, the upgrade insecure requests directive can be used in a CSP in isolation. So you don't need to restrict any content to enforce secure network connection using a CSP. So another thing that is very important for the web is the presence of cat pictures. Well, everyone loves them, right? And for sure, everyone wants to see more of those cute cat pictures. But clicking on buttons can be dangerous because of attacks, of framing-based attacks, like, for example, clickjacking, where an attacker loads another application in an overlay and basically places this with high opacity over the button that you want to click. So, to see how familiar everyone is with frame control, we again want to see a few hands here. So who of you is actually aware of framing attacks, like, for example, the click-checking attack that you've just seen? Okay. And who of you actually uses X-frame options to defend against these kind of attacks? Okay. And we think that X-frame options might not be the best solution to defend against frame-based attacks. Okay. And who actually knows the CSP directive that can be used for framing control? Okay. So, let's first start with the X-frame options header. Well, the X-frame options header has certain problems because it was never standardized, and therefore browsers inconsistently implemented this header. So, this inconsistent implementation leads to security problems, like, for example, the partial support of some modes and double framing attacks, which we will see in a few seconds. But also, it has as well functionality problems, because in X-frame options, you are only capable of whitelisting one single origin. which is bad because in many cases you want your application to be framed by multiple other parties. So, as mentioned, there is the problem of partial support for the X-frame options header. And as you can see here, major browsers like, for example, Chrome, Opera, and Safari don't support the allow from mode of the X-frame options header. And that's why if you deploy the X-frame options with this mode, they fail insecurely. So users with that browser basically have no framing protection at all. Another problems are so-called double framing attacks, where these kind of attacks basically occur because in X-frame options, or in some implementations of X-frame options, the origin that is checked against is only the topmost frame and not all framing ancestors. And that's why, well, if a page with XFO enabled frames an attacker page that again frames the page, the X-frame origin is okay with that. So, to fix all those problems, CSP Level 2 has introduced a new directive called frame ancestors. And as you can see here, also this use case is used by around 1/3 of all policies in the wild. But how does frame ancestors actually address the problems of the XFO header? Well, first of all, as mentioned, the XFO header is inconsistently implemented, but CSP is a well-defined standard in level 2. In CSP level 2, frame ancestors is a well-defined standard in CSP level 2. And that's why it also fixes the problems of partially support, because all modern browsers that actually support CSP level 2 also support frame ancestors. And because it is a well-defined standard, everyone implements it the same way. And according to the specification, all framing ancestors needs to be checked and not only the topmost frame, which also fixes the double framing problem. Another cool addition in comparison to XFO is the support for an explicit whitelist. So you can whitelist multiple parties that are actually capable of framing your web application. And again, just like in case of TLS enforcement, the frame ancestors directive can be used in isolation. So you don't need to restrict any of the page's content to secure your web application against framing-based attacks. However, not every browser that is out there supports CSP level 2, for example, the Internet Explorer. And therefore, there are some best practices that you need to keep in mind if you want to deploy frame ancestors. Well, in modern browsers where CSP level 2 is supported, as soon as frame ancestors is present in the CSP, the X-frame options header will be ignored. That's why you can secure, for example, securing your web application through a combination of an X-frame options header that denies all framing, and your frame ancestors directive that actually allows the sites that you want to allow. For example, save. And Ben will now take a look with you into how these nice and new features of CSP are actually.
All right, thanks, Sebastian. So we've seen that XFO has these particular issues, and so this would be a policy that would be secure by default, and you would break Internet Explorer. But then again, is that really a problem or not? But in any case, you'd say, okay, obviously with frame ancestors, it's very easy. I have a whitelist, so it works well in terms of functionality. So obviously everybody's going to use frame ancestors, right? And here's a graph that shows exactly this. So the red line is the adoption of X-frame options with the deprecation around 2013. And we see now it's being used by over more than 3,000 of the 10,000 sites, whereas CSP for framing control is actually used by, I don't know, 500, 300 or something. So essentially people are still increasingly using this super outdated header, which had all these issues that we just discussed, instead of the well-specified frame ancestors directive. We also find that there's a lot of people who use both. So they might have seen the previous slide in terms of best practices, how you can combine the two headers. And so we thought, okay, this is somewhat bad, right? So why is the situation this dire that we see people using this super old header? So we did a small notification. So we had about 2,700 sites that did not use CSP frame ancestors but used XFO. And so I've done notification experiments before. So I said, okay, it's 2.5K sites. The response rate will be 1% or so. So I'll just use my own inbox and send a couple of emails out. So a lot of them bounced. But overall, what I was very surprised about is that I got responses from 120 people. And these went above just saying, thanks for your email. These were as like, can you give me more information? So I spent about a week or so answering all these emails, engaging with people back and forth. And then at some point I said, okay, this is just way too much. I don't want to look at these emails anymore. So that's what you have PhD students for. So I asked Sebastian to actually have a look at those policies and try to kind of come up with categories that they fit into. And so 62 people said, awesome, thank you. Great that you told us. We'll deploy this right away. Not all of them have until this very day, and this has been a couple of months ago. 24 people directly replied to me and said, you know what, CSP is so complex, it will break my website, right? So this already gives us some indication of people not knowing that they can use frame ancestors in isolation. And we have a couple of codes also in a second. And then there were 13 people who were running X-frame options who said, well, we have never actually heard of CSP frame ancestors before. So we also asked them in a follow-up survey, like, why are you even using XFO? But we'll come to that in a second. I want to share just a couple of the things that we got. Again, it's 117 responses, so I'm not going to show you all of them. But let me show you this one first. So the term complex is something that happened a lot, that we got a lot in the emails. I also sometimes like to call it CSP complex security policy, which probably fits its description much better than content, because it's, as we've seen, used for framing control. That's not content security anymore. So what does it say? So some of our partners are iframing our site. We already had issues implementing the X-frame options header, so we didn't want to deal with it again with CSP. So there's a clear misconception here that if you have X-frame options, what you need to do is if you have multiple partner sites that frame you need to, on the server side, decide what's the referrer that I'm seeing right now, and do I want to specify X-frame options allow from this particular referrer or not? With CSP, this is much easier because assuming that you know who's going to frame you, you just have a whitelist that you can fix once and you don't have to dynamically decide which thing to use. So here there's a clear misunderstanding about the capabilities of CSP. The second one, and that was we've seen in the very beginning with the questions that I was asking, CSP destroys websites. I fully agree that if you try to restrict your content, CSP will break your website. And so there were people, and again, this is just one example, we had more like these, that told us, yeah, that was already placed on the roadmap in August last year, but we went into some troubles probably enabling this, so we stopped using it. Okay? So this is obviously not Airbnb, because Airbnb just does have enough staff to, well, then address these issues and try to come up with a solution that works. Then again, the complexity, right? Many first and third party integrations. I think also third parties are a very big problem of CSP, because you can make your site as secure as you want to. When you then run Google Tag Manager, it will use eval or document write, right? So you're screwed again, essentially. And so they said, yeah, we like even having a generic policy that adds value and which is suitable for our entire estate is something that is very difficult to achieve. This is probably one of those cases where we saw before, 90% unsafe inline, right? It's possible to deploy a CSP, and if your boss tells you need to deploy a CSP, you have deployed a CSP successfully. But if you have to resort to unsafe inline, to HTTPS, to unsafe eval, and then even add the data and the blob URL scheme, then obviously, yes, you have deployed CSP, but due to functionality issues, you had to just back down a little bit and, go and find a better solution or just have these very insecure practices. And then this is another example of this massive engineering effort, and I like this a lot. So we have a small team. Do we want to update our version of Python, or do we want to add CSP? Do we want to move to the new LTS version of Ubuntu or CSP? And there were a couple more of these things, and then they said, well, CSP is always going to lose. And obviously, thank you. And obviously, I think this is something that you've all experienced, that it's such a significant effort. You can't just say, okay, I'll just deploy a CSP and this will work out fine. And we've really seen this quite a lot, where we saw policies which I found frustratingly insecure. Say unsafe inline, HTTPS. Okay, so how much more insecure can you get? Well, you have to add the data URI, because some third party adds a script as a data URI, and you also have to add the blob URI scheme, because somebody creates dynamically a blob and then puts that as a script into your page. Okay, so you have this already insecure policy which you still need to widen even further, and then you could just not do it at all, I guess. Okay, so since we got all these emails back, we also said, let's try to do this a little bit more, well, formal and structured. So we asked people to participate in this survey. And so the first question was like, why have you even implemented this XFO header? And most of the people that answered said they did this based on their own decision. Maybe they were at OWASP, they were aware of the threats around this, followed the guidelines there. But almost equally as many people said, well, there was either a pen test or a consultant that told us, or a tool that suggested XFrame options. And it did not suggest frame ancestors. And so if you write a tool, or if you're a consultant, then please consider also telling people maybe also implement frame ancestors, because there's no harm for a modern browser. Okay, the modern browser will ignore XFO and will instead use CSP frame ancestors. You can still use XFO for the legacy browsers, which is perfectly fine. But just help us improve the situation. And so there are many more questions, but I just wanted to, in the interest of time, show you one more, or two more actually. So we asked people, it's like, do you believe CSP is viable to increase your site's resilience against XSS attacks, right? So that's what people initially came up with CSP. It was like, we want to mitigate cross-site scripting. They said, yes. Well, essentially everybody said yes. So there was one person who said nope, and one person who said, I don't really know. And then we asked the second question, would your site work out of the box if you deployed a script content restriction CSP today, disallowing eval, inline scripts, and event handlers? And guess what? Now the answer is exactly inverted. Naturally, essentially everybody was saying no. There's a couple of people who don't know, but probably also because they are not as aware of CSP. For example, if you only have inline scripts, you can use nonces. If you have inline script and event handlers, you're screwed again. And as Sebastian already said, this is something that we have observed quite a lot. And in contrast, in our experiment, we saw just a handful of sites that managed to do a secure CSP. And those were the sites that either did not have any inline event handlers before they started CSP, or very few that they could easily eradicate. Okay? But I think many of you have looked at applications or even built applications where this is not the case. All right. So let's have a couple of takeaway messages, and then I have a couple of questions or wishes to the audience as well here. So CSP for script content control, as we have seen, is way too complex, and it does give CSP a bad name, because as we saw also from our responses, people say, CSP, no, will break my site. So they don't even understand that you can use these two useful modes of CSP in isolation. For those, it's actually very useful. So for TLS enforcement, you can, using upgrade and secure requests, seamlessly migrate to HTTPS, and then just assuming that all links also work over HTTPS. And as we've seen in the experiment that Sebastian did, a lot of the pages that do still rely on HTTP resources could, at least based on the start pages, upgrade right away to TLS. It's also very useful for framing control, and the misconceptions about CSP and the unusable content control mechanism really block the usage of the easy-to-use features. So it even just gave me the 5 minutes, but I'm also done now, so thank you. So this is where I would like you to help us out a little bit. I told you before that essentially we did this study, and we wrote a paper about it, and then the reviewers told us, but how do you know that these are actually people who are developers and who are knowledgeable about CSP? And I said, well, we don't, but I didn't get the feeling that there was like the secretary just answering random emails saying, please give me more technical information about CSP. However, in this room, there is an audience full of experts of CSP. And if you could help us out, it will take you no more than 3 minutes, unless you write a very, very long comment in the free text. It would be super useful if you could help us out with a small survey here. And since we already we still have a couple of minutes left. So that's why I would like to now open the floor for any questions, and also would like to hear your personal kind of horror stories about CSP and what you think should be done to improve it. So thank you very much.
Any question?
Oh, yeah. So you mentioned having Google Tag Manager and other XSS as a service. How do you deal with that?
That's an excellent question. So especially Google Tag Manager, I saw a lot of people whitelisting the origin, HTTPS googletagmanager.com, which is super bad because I think nobody really understands that me as the attacker, I can just upload my script there and it's hosted there. So in this case, assuming that you don't have any open redirects in any of your other whitelisted sources, you could whitelist the entire URL, right? When you have open redirects and there's issues about CSP and privacy, but so if you don't have that, then you should be fine with explicitly whitelisting the URL or not rely on Google Tag Manager.
Yeah, but you also need to do unsafe inline for the injections. So
that is the second answer to my question. Don't use Google Tag Manager. Don't quote me on that, please.
Oh yeah, I will quote you.
So one of the problems that I've come across trying to put CSP things on, obviously you mentioned like inline is something you want to do and you want to put a nonce on that where possible. Now, I don't have a huge amount of experience with WordPress, but a friend of mine's site got hit and he wanted me to fix it up for him. A lot of frameworks, it seems, do not allow you the easy way of putting in a nonce because that has to be put in on server side. That has to be put in so that it matches in the header and what gets put into the HTML. Now, especially in WordPress, I'm assuming that this attacker managed to get in, put a script in a WordPress plugin, blah, blah, blah. That WordPress plugin would have access to that nonce if the WordPress was adding in the nonce. So that mitigates that entirely, even if I did put in a nonce, but I can't even get a nonce in. You know what I mean? So I think that's probably one of the problems we see a lot is how, even if we can use these nonces, it's a big technical implementation unless you've got if you're customly writing your website and you have your own server and you're writing how it serves it, it's really easy to implement a nonce, but a framework's going to do that.
That's an excellent point. And I think it also echoes, I talked to some people from Joomla and I think they are thinking about adopting CSP in somewhat strict CSP for like when they deploy Joomla, but ran into similar issues, right? Because in these cases, even if like the main contributor, WordPress, wants to enable CSP, you have third parties, which are the plugins in this case, which screw you over. And it's the same for the JavaScript world as well, because you have Google Tag Manager that uses document writer in HTML or eval, and other things like this as well. So this is an excellent point. Thank you.
Do you think script source LM will prevent the event handler issue?
So essentially, you will have to hash event handlers, right? You cannot nonce elements. I think that's always going to boil down to the issue. And so what we've seen, and Sebastian ran some experiments just recently, there were sites that had, when just crawling the start page, 3,000 different hashes that you'd need for event handlers. That was based on bad programming style anyways, but you'd have to first kind of figure out a way to make a handler generic enough to fit for an individual element. And then also I think Chrome now has this unsafe hashed attributes, where you can explicitly say, yes, I allow a hashed script to be attached to this or to some attribute, because there is a bit of danger because you can manipulate, like if you have a specific element and you take an event handler that just evals, I don't know, like the content of the element, then you're screwed it because the attacker could use this. So there is this. I personally think about maybe, again, this is a super personal opinion. If we could nonce other elements than scripts, there would be a potential danger for stealing nonces. But the question is right now, you can either be totally insecure because of unsafe inline, or you can be totally secure and break your application. So if we find some middle ground, that would be very useful. I have to think about this a little bit more and do some experiments, but this might be a possible way to go in the future.
Yeah, hi. Do you have a list or something for, say, order of precedence for all kinds of the headers and all fun stuff you can do with which HTTP combination I think about is have the CSP rewrite everything to HTTPS, and you also have HTTP's strict content transport security. if the rewrite happens after, you just brick your site. If it happens before, it would just work. But the order of precedence, is there a standard? Is it documented somewhere of all those things combined?
We did experiment with this. Do you want to say something for Firefox? UAR happens before block all mixed content, right? So essentially, it's like look at the page. Then, if you see HTTP resources, try to upgrade them if UAR is there, and then you go with the other directives. Which is also why if you have upgrade insecure requests and block all mixed content, the second one is essentially a no operation, because UAR would try to upgrade it, and if it doesn't work, it would not include it, and then block all mixed content has nothing to block anymore because everything is HTTPS already. So there is this precedence that first UAR and then the evaluation of the policy. Is that correct? Really?
Yeah, I think you also asked about HSTS. I think the other is HSTS.
Okay. So you would first block something even though it's HSTS.
In comparison to we first upgrade.
Yes, and then have HSTS later on. Okay.
Okay, that's sensible. But that's a standard that goes for all browsers, or?
Well, it's a standard.
Yeah.
So probably not on Microsoft products.
That's usually the problem. Yeah, there's an RFC for that, but yeah, then it breaks in Apple browser or something.
So Firefox is quite interesting.
Yeah.
So for the video, Firefox is awesome.
I know. I wish everybody would use it, but yeah.
All right. Thank you.